Hello students, how are you all? I hope everyone is doing well. So today we'll be starting with one new chapter, that is the chapter on circles. Okay, so let's start today's class. So as you all know, what is circle? So it's a round figure, right? And if we take it in x and y axis, then what is the angle? What will be a circle will make an angle of 360 degree. You all know this thing, right? So when we have seen many figures which are round, so we call them as circles. Okay, so circles and its related terms. So if I draw one circle, okay, if I draw one circle, say this is a circle. Okay, if this is a circle, then this is the boundary of the circle, right? So we will call this as, we will call it as circumference, right? We will call it as circumference. And circumference is nothing but, it is the perimeter, right? It is the perimeter. Okay, we all know this. So this is the center of the circle. Okay, let this be the center of the circle. Now if I draw one chord, say this one is the chord passing through the center of the circle. So this is the longest chord, right? This is the longest chord, and we call the longest chord as, what is the name of this longest chord? It is known as diameter. Diameter, right? We call the longest chord as diameter. And if I take only this part, then what is it called? It is called as radius, right? So diameter is equals to twice radius, right? So diameter is always twice radius. Why? Because this one is the first radius, and again this one is the second radius, right? So if we add to the radius, then we will get the diameter. Okay, now see here, if this is a circle and this is the radius, say its length is suppose 1 centimeter, then if I draw any radius on this circle, it will definitely have some length, right? So all the radius within a circle have the same length. So that means if this is 1 centimeter, then this is also 1 centimeter, this is also 1 centimeter, this is also 1 centimeter. All will have the same length. Okay. Okay. Now see here, what is the general definition of a circle? The collection of all points in a plane which are at a fixed distance from a fixed point in a plane, which are at a fixed distance, right? Which are at a fixed distance. That means if I draw the circle with one compass, it will have a fixed distance. Okay, from a fixed point, this one is the fixed point, that is the center in a plane is called a circle. The fixed point is called the center. Okay, the fixed point, this fixed point is known as the center, and the fixed distance is called the radius of the circle. This is the fixed distance, right? So we call it as the radius. Okay, and I have already mentioned that all the radius within the circle have the same length. Okay, now note that the line segment joining the center and any point on the circle is also called the radius of the circle. That is, radius is used in two senses, in the sense of a line segment and also in the sense of length. So we call this radius as line segment also, or we can call it as a length also. Okay, now see, inside the circle, which is called the interior of the circle. So this whole inside part, we call it as the interior. We call it as interior of the circle, and the outer part we call it as exterior, right? We call it as exterior of the circle. Okay. Now, see here. The circle and its interior region make up the circular region. So, as I have already mentioned that a diameter is the longest chord and all the diameters have same length, which is equal to 2 times the radius. So, diameter is equals to twice times the radius, right? And the diameter is known as the longest chord. Okay? Okay. Now, see, if I say suppose this one is a circle, let this be a circle. Now, if I cut this circle at this point, okay, so this point, let it be P and Q. So, this part is known as the arc. Okay, it is called as arc, A-R-C. It is known as arc. Okay, and see, since this is the smallest part, right? This is the smallest part, so we call that as minor arc. Okay, and since this whole part is the bigger part, so we will call it as a major arc. Okay, major arc, and this is the chord. Okay, understood? So, we denote this minor arc PQ like this. Okay, we always denote the arc as like this. We will write the points and draw this arc. Okay, line segment, we always draw it like this. PQ is a line segment. PQ is a line segment. We will draw it like this. But if it is a PQ is a arc, then we will put this segment. Okay, fine. Now, see here. So, this one is the minor arc here, and this is the major arc. And if this is the center of the circle, and if this is the longest chord which is passing through the center of the circle, then obviously it is cutting the circle into 2 equal halves. This is the first half and this is the second half. So, we only call this part as semicircle, right? We will call it as semicircle. Okay, understood? So, see, the length of the complete circle is called its circumference. As I have already mentioned, the length of the complete circle, this is nothing but the length of the circle, and we denote it as circumference. And circumference is nothing but the perimeter of the circle. Right? What is the perimeter of a circle? It is twice pi r. Right? Perimeter of a circle is twice pi r, as you have already studied in the earlier classes. Okay. So now see here, some important things you need to know. Say for example, this is a circle. Okay. Now, this is the center point, and I have drawn a radius, 2 radius, which are of equal lengths. As I have already mentioned that radius within a circle have equal lengths, right? So, now, this part is called as sector. Okay. Now, what is a sector? Say for example, you are visiting your friend's house, okay, and you have asked him or her the location of your friend's house. So, your friend told you that, okay, I live in this place, so you come to this place and give me a call. Okay, so you went there and you went to that particular sector. Okay, that whole area which your friend has mentioned as the location. You come to this place, so you have gone to that place and called your friend. So that whole part will be called as a sector. Okay, or else there is a whole cake and your birthday cake, and you are cutting that cake. When you cut the cake, you pull up one part and give it to your friends. So that part is known as that whole part is known as the sector. Okay, so you had went to that place and gave a call to your friend, asking him about the exact house. Which one is your house? So you have called your friend and asked that, I have reached here, and now tell me your house or house number. You can tell me your house number or which floor you live in. So your friend told that, I live in this exact location, and my house number is say 1, say 2, 3, say 3, anything. Or else your friend had said that in this particular area I live in this apartment on the first floor. So if you visit to that particular place and the exact location, that means this part, that is the first floor or that particular house. So this part is known as the segment. Okay. So what is sector? Sector is the whole area, right? And what is segment? Segment is the particular point. That particular point, the first floor or second floor or third floor or any house number. Okay. So that particular point is the segment, and the sector is the whole area. So for example, sector 1, sector 2, sector 3. In that sector there are many apartments, right? So in that particular apartment will be segment here. So since this sector is the smallest part, so we call it as minor sector, and this whole part we call it as major sector. Major sector, right? And since this segment is the smallest part, so we call it as minor segment, and the rest of the part we call this as major segment. Okay, this is the difference between minor and major. Minor means the smallest part, and the major means the bigger part. Okay, so this is what it is written here. Okay, you just go through it and you will be understanding the whole concept. This is the basic concept, and using this we will be doing now the exercise 10.1. Okay, so now see here the first question. See the first question here. The center of a circle lies in the dash of the circle. The center of a circle. The center of the circle. This is the center of the circle, and it lies exterior or interior. Since this is the interior part, so it lies in the interior of the circle. Okay, understood? Easy? Okay. Next, a point whose distance from the center of a circle is greater than its radius lie in the dash of the circle. A point whose distance from the center of a circle is greater than the radius. Is greater, say this radius. Say for example, this is a circle and this is the radius of the circle, which is 1 centimeter, and it is written that a point whose distance from the center of a circle is greater than its radius. That means there is a point outside the circle which is greater than the radius. So the point will lie in the interior or exterior, since this part is the exterior. So it will lie in the exterior of the circle. Understood? Next, the longest chord of a circle. As I mentioned that the longest chord always passes through the center of a circle. So the longest chord is the diameter of the circle, right? It is the diameter of the circle. So you write here diameter. Okay, it is the diameter of the circle. Next, an arc is a dash when its ends are the diameter of a circle. An arc, say for example, this is a circle, this is a circle. An arc, so what will be the arc? This part will be the arc, right? And this is the center of the circle. When its ends are the ends of a diameter, when it ends, this is the ends, are the ends of a diameter. So what is it looking like? It is looking like a semicircle, right? It is looking like a semicircle. So here an arc is a semicircle, semicircle, when it ends are the ends of a diameter. Next, segment of a circle is the region between an arc and dash of a dash of the circle. Segment of a circle is the region between an arc so segment of a circle is the region between an arc and dash of a circle. So this is the circle and this is the segment, right? We call it as segment. So it is written as segment of a circle is region between the arc and what is this line called? It is known as a chord, right? And chord of a circle. So we can write here chord. Next, a circle divides a plane on which it lies in how many parts? A circle divides a plane. This is a plane, okay? And the circle divides the plane in how many points? A circle divides the plane on which it lies in how many points? This is a point, this is a point, this is a point. So in 3 parts, right? In 3 parts, okay? Now the next question, write true or false, give reason for the situation. So the first one, line segment joining the center to any point on the circle is a radius of the circle. Is it true or false? Yes, it is true, right? Next, a circle has only finite number of equal chords. There are, how many chords can be there? There are finite numbers or there can be infinite numbers. There can be infinite numbers. So it can be infinite numbers. So this is false, right? The first one is true. Next, a circle is divided into 3 equal arcs. Each is a major arc. No, it can be major, it can be minor, right? It can be anything. So this is also false. Next, a chord of a circle which is twice as long as its radius is the diameter of the circle. Yes, the longest chord is the diameter of the circle. Sector is the region between the chord and its corresponding arc. No, it is, if this is the chord and this is the corresponding arc, then we call this part as the segment. So this is false, okay? A circle is a plane figure. Yes, circle is always a plane figure. It is true. But if that circle, if I add 3 circles, so it will become a sphere, and sphere is a 3-dimensional figure. Okay, but circle, we always draw a circle on a sheet of paper. Okay, so it is a 2D figure. So it is a plane figure. Understood? So this is all about exercise 10.1. Now, the next part, angle subtended by a chord at a point. So now see here. Here you have one theorem. So you need to know this theorem very, very well because it is very, very important. Okay, theorem 10.1. So now see here. Equal chords of a circle subtend equal angles at the center. As I have already mentioned that equal chords of a circle subtend equal angles at the center. How? You need to know this. Now see here. There is one circle. Okay. Now there are 2 given chords. Say this AB is a chord. This AB is a chord. This is a chord. And CD is a chord. Okay. These are 2 chords of a circle. With center O. This O is the center of the circle. Now what we need to show that? We need to show that this angle AOB, this angle AOB is equals to angle COD. That means the angle subtended by equal chords of a circle are equal. We need to show this. That means this angle and this angle are always same. We need to prove this. So in triangle AOB and COD, what we have? We have OA is equals to OC. Why? Because they are the same radius, and we have already read that radius within the center of within the circle are always same. So that means their radius will be definitely equal. Okay. Again, we have OB is equals to OD, OB is equals to OD. This is also the radius. So all the radius will have the same lengths. Next, AB is equals to CD. Since they are two equal chords, so definitely the two equal chords will be equal. So what criteria we have? This is side, and again this is side. So that means side criteria. We have that these two triangles AOB and COD are equal by which criteria? Their congruence criteria, right? Side, congruence criteria. And we know that corresponding parts of congruent triangles are always equal. We have studied this thing very well in the chapter triangles, right? Corresponding parts of congruent triangles are always equal. So definitely their angles will also be equal. So angle AOB is equals to angle COD. Understood? Okay. Okay. So remember just one thing, that equal chords of a circle subtend equal angle at the center. Okay? Okay. Moving on to the next theorem. So this is just the converse of the first theorem. So if the angles subtend by the chord of a circle at the center are equal, then the chords are equal. So what we have studied first, that equal chords subtend equal angle at the center. But this time, if the angles subtended at the center of a circle are equal, then the chords will be equal. That means this is the converse of the first theorem. Okay? So here this is just the theorem 10.1. So I will not do this, just do it as your homework because this is nothing but theorem 10.1 only. Prove that if chords of congruent circles subtend equal angles at the center, then the chords are equal. Both these are theorem 10.1 and theorem 10.2. It is given as exercise also. So please do it as your homework. Okay? Okay. Moving on to the next part, that is the perpendicular from a center to a chord. Okay, if I draw one perpendicular to the chord through the center, then what will it form? Theorem 10.3. This is very important. Now see here, the perpendicular from a center of a circle to a chord bisects the chord. Bisects means it cuts the chord. Okay, the perpendicular from the center of the circle bisects the chord. Okay. So just you need to know this line, otherwise the proof is not important and it is also not given here, so you don't need to know the proof. Just you need to know that perpendicular of a chord, perpendicular from the center of a circle bisects the chord. Theorem 10.4. Now see here, the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. The line drawn through the center of a circle to bisect the chord is the perpendicular to the chord. This OM is perpendicular to AB. This is what we need to prove. Okay, that means this angle, if this is the perpendicular, then definitely OMB and OMA will be 90 degree each, right? Since a line, linear pair is always 180 degrees, so this, if this is the perpendicular bisector, then definitely these two angles will be 90 degree each. Okay, so this is the chord AB with center O, right? M is the midpoint and we have joined OM. OM is the perpendicular of AB. And we have also joined OA and OB. Now, these are two triangles, OAM and OBM. These are two triangles. So, in these two triangles, now, OA is equals to OB. Why? Because already we have mentioned that radius within the circle are always equal. So definitely OA is equals to OB. These two sides will be equal. This is the side criteria, right? Next, AM is equals to BM. AM, that means this part is equals to this part. Why? Because we already know that if there is a perpendicular bisector of a chord, then it divides the chord into two equal parts. So therefore, AM is equals to BM, right? Since OM is the perpendicular bisector of AB. You can write here, since OM is the perpendicular bisector of AB. So this is also side criteria. Again, OM, this part, that means this perpendicular is common to both the triangles. So that means this side will always be equal for both the two triangles. So this is also common. So that means this is also the side criteria. So what we have now? Side, side, side. That means by side, side, side congruence criteria, we have that these two triangles OAM and OBM are congruent, right? And we already know that by corresponding parts of congruent triangles, that is CPCT rule, we already know that their angles are always equal. So therefore, this angle OMA is equals to OMB, which is equals to 90 degrees. Understood? So this is the proof of the theorem. The line drawn through the center of a circle to bisect the chord is perpendicular to the chord. So we have proved that this OM is the perpendicular bisector of AB. Understood? Okay. Moving on to the next part. Circle through 3 points. So if we draw circles through 3 points, any 3 points, so it will definitely look somewhat like this, right? And if the 3 points lie on the same plane, then we call it as collinear. But if the points are here and there, we call them as non-collinear. Okay? Okay. So we have theorem 10.5. If there is one and only one circle passing through three given non-collinear points. There is only one and only one circle passing through three given non-collinear points. That means, what is written here? These points are non-collinear. Why? Because as I have already mentioned, see, if these are the points, they are in a straight line, right? So we call them as collinear points, right? But this point, this point, this point, they are not on the same line. So we call them as non-collinear points. Okay? Now, you can observe that only one and only one circle can pass through these three non-collinear points. Only one circle can be drawn through these non-collinear points. This is only written here. There is only one and one circle passing through three given non-collinear points. Okay. Now, what remark is there? If ABC is a triangle, then by theorem 10.5, that is using this criteria, non-collinear points, there is a unique circle passing through three vertices, that is A, B, C. If we join these points, then it will be a triangle A, B, C, right? This circle is called the circumcircle of the triangle ABC. That means, if it is meeting the vertices of the triangle, then this circle is known as the circumcircle. This circle is known as circumcircle. Okay? Its center and the radius are respectively called the so this point will be the center of the circle, right? It is known as circumcenter, and this is the radius of the circle. So we call it as circumradius. Okay? Circumradius of the triangle. Understood? So now, exercise 10.3. So this is, I don't think that this is the most important. 1 and 2, you just do it as your homework. This is not so important. Question number 3. If two circles intersect at 2 points, prove that their center lie on the perpendicular bisector of the common chord. So, for this, we have to do the proof. Okay. Now, okay, let us do question number 3 of exercise 10.3. Okay. Question number 3. See, if two circles intersect at 2 points, that means there are two circles. Okay. Let this be the first circle and this one be the second circle. Okay. Intersect at 2 points. That means they are intersecting each other at 2 points. Say these are the 2 points. Let me join this point and say this as P and Q. Okay. Now see here. Prove that their center lie on the perpendicular bisector of the common chord. This is the common chord. Since the two circles are meeting, intersecting each other at 2 points, so this is the perpendicular bisector. So if I join their two radius, so this perpendicular bisector, prove that their centers lie on the perpendicular bisector of the common chord. Okay, and let me join these 2 points. Okay. Okay. So this point B, let this point be R, let this be O and O dash. Okay. Okay. So given, first of all, given two circles of radius of center O and O dash intersect each other at point P and Q. Okay, each other at point P and Q. Now, what we need to prove? To prove, first of all, O dash is the perpendicular bisector. Okay, of PQ. So, number 1, PR is equals to PQ. First of all, we need to prove that this part PR is equals to PQ. And next, we have to prove that angle PRO is equals to angle PRO dash. That means this angle is equals to this angle, and QRO, this angle is equals to QRO dash. So, number 2, we have to prove angle PRO is equals to angle PRO dash, which is equals to angle QRO is equals to angle QRO dash, which is equals to 90 degree each. So now the proof. See, now see, in triangle PO and O dash. That means let us take this triangle first. Okay, and next Q, O and O dash. This is P, this is O dash, and Q, O and O dash. Let us take these two triangles. So, in triangle POO dash and triangle QOO dash. So, what we have? OP is equals to OQ. OP is equals to OQ. This part is equals to this part. Why? Because they have the same radius, right? So, we can write here same radius, right? Again, we have C. O dash P, this side is also equals to this side because this is the radius of the smaller circle. So, this radius will be also equal. So, O dash P is equals to O dash Q because they have the same radius, right? And also, we have this side, O dash. This is the common side for both the triangles. So, therefore, it will be O dash is equals to O dash. Why? Because it is the common side. Okay, that means what criteria we have? This is side, and this is side. So that means by side criteria, we have that triangle POO dash and is congruent to triangle, congruent to triangle QOO dash. Right. So therefore, what I can say? Therefore, by CPCT, by corresponding parts of congruent triangles, what I can say? That this angle POO dash, that means this angle is equals to this angle QOO dash, right, by CPCT. Therefore, by CPCT, angle POO dash is equals to angle QOO dash, and let this be equation number 1. Similarly, for triangle, now see here, now let me take this triangle POR. Okay, let me take this triangle POR, and let us take this triangle QOR. That means this triangle Q, this is QOR. Okay, so they have the same angles because this is the perpendicular bisector, so definitely this side will be equal. This is the radius, this side will be equal, and this is also, this side is the common side, this is also equal. So similarly in triangle, we can show that similarly in triangle POR and triangle QOR, we can show that angle see PRO is equals to angle QRO. Why? By CPCT. PRO is equals to angle QRO. How? By CPCT. And both these triangles are what? They are congruent, right? They are congruent. So you can write it like this. So let this be equation number 2. Now see here, since this PQ is a line, right? Line segment. So you can write here as PQ is a line. So definitely angle PRO plus angle QRO is equals to 180 degree. Linear pair is always 180 degree. So what is angle PRO? It is QRO is equals to angle PRO from 2, right? So angle PRO plus angle PRO is equals to 180 degree from equation 2. So which implies twice angle PRO is equals to 180 degree. So that means angle PRO is equals to 90 degree. Right? So what we have? So angle PRO is equals to angle QRO is equals to 90 degree. Right? And we already know that. See here. See the diagram. PRO dash, this angle. QRO, these are vertically opposite angles, and these are vertically opposite angles. So what we can write? We can write that angle PRO dash is equals to angle QRO is equals to 90 degree. Again, angle QRO dash is equals to angle PRO, which is equals to 90 degree. Why? Because they are vertically opposite angles. You can write here vertically opposite angles, right? Since they are vertically opposite angles. So therefore, comparing all this, what we have got? We have got that O dash is the perpendicular bisector of PQ, right? And this is the required, hence proved. Okay, so we'll be stopping here today. In the next class, we'll be moving on to the next part, that is equal chord and their distance from the center. Okay, revise this thing very properly in homework. Okay, thank you.